So the focus for today is on the applications of nature of roots. So let's look at the first one. It says if the equation p into x squared plus x equals -9 has equal roots, and it is given that p is a non-zero number, determine the value of values of p for 5 marks. So this is the equation we are given. It's p into x squared plus x, which is equal to -9. So the first thing we do is to write the equation in standard form. So we distribute the p, and then we take -9 to the left, so it becomes positive. So this is what we have. Then from this point, we need to calculate delta. So we say delta equals b squared minus 4ac. So the value of b is p in this case. So it's going to be p squared minus 4 into the value of a is still p, and the value of c is +9. So you're going to have p squared minus what? 4 times 9, it's going to be 36. And then you still have your p. But they said the roots of this equation are equal. So we have to tell them that for equal roots, delta has to be equal to 0. So we say p squared minus 36p equals 0. Then we see that p is the highest common factor. If we take it out, we are left with p minus 36. And this is equal to 0. Then we apply the zero factor law. So we say p equals 0 or p equals 36. But if you remember in the statement, they said p is non-zero. So we have to tell them that p equals 0 is not a solution. Therefore, the solution to this one will just be p equals 36. And then you are set. So let's look at the next one. Now this one says, if the roots of the equation mx squared plus 5x plus 4 equals 0 are non-real for all values of m that are non-zero, calculate the least integral value of m. So the word integral comes from the word integer, which means a whole number. It can be positive or negative as long as it's a whole number. So in this case, therefore, we are looking for the smallest whole number value of m, for which the roots of the equation will be non-real. So we go to the whiteboard. So the first thing we do is to write the equation as it is. They said the equation is mx squared plus 5x plus 4 equals 0. So because it's already in standard form, we can go ahead and calculate delta. So we know that delta is b squared minus 4ac. The value of b here is 5. And then the value of a is m. The value of C is 4. So 5 squared is 25. Then 4 times 4 is 16. So you have 16m. Then you tell them that in order for the roots to be non-real, delta has to be negative. What goes inside the square root must be negative. So you say 25 minus 16m is less than 0. Then from this point, you can take 16m to the right, so it becomes positive, or you can take 25 to the right, so it becomes negative. Then you'll divide both sides by negative. Are we fine? But it's not necessary for you to divide by negative. You can just take the negative 1 to the right so that it becomes positive. But I want you to see what is going to happen. It's 25, and then you have your sign, then you have 16m. Do you see that? How do you read this? You are saying 25 is less than 16m. In other words, you are actually saying 16m is greater than 25. Are we fine? Then from this point, we divide both sides by 16. So we find that m must be greater than 25 over 16. So if you press 25 over 16 into your calculator, you get 1.56. But the question is not looking for a fraction or a decimal. It's looking for a whole number. So what is the first whole number to be greater than 25 over 16? It's just going to be 2. Do you see that? This is the least integral value of m. The whole number, the lowest whole number, which is the first to be greater than 25 over 16. And then you are happy. So let's look at the next one. Well, this one says, for which values of p will the roots of the equation x squared plus 4x plus p equals 0 be real? Do you see that? So once again, the equation is written in standard form. It is x squared plus 4x plus p, which is equal to 0. So we can go ahead and calculate our delta. So the value of b is 4. The value of a is 1. The value of c is 4. Sorry, c is p. Sorry about that. So you say 4 squared, you get 16. Then you say 4 times p, it's just 4p. Then you tell us that for the roots to be real, delta must be greater or equal to 0. So you say 16 minus 4p is greater or equal to 0. Then you take negative 4p to the right. So you have 16, which is greater or equal to 4p. But in the actual sense, you are actually saying 4p is less or equal to 16. Then you divide both sides by 4. Then you find that p is less or equal to 4. So any value of p that is either 4 or less than p, the roots of this equation will be real. Right. Then the last one says, determine the values of P for which the equation x squared plus 6x plus 2p minus 3 equals 0 will have real roots. So it's more or less the same as the one we just did. The equation is x squared plus 6x plus 2p minus 3 equals 0. So it's already in standard form. We can go on and calculate our delta. So the value of B is 6. The value of A is 1. The value of C is 2p minus 3. The whole of this is just a constant. There is no variable there. Now 6 squared is 36. And then 4 times 1 is just 4. So you can say negative 4 times 2p, you get negative 8p. And then you say negative 4 times negative 3, you get positive 12. So 36 plus 12, it's going to be 48. And then you have negative 8p here. Then you tell us that in order for the roots to be real, delta has to be greater or equal to 0. So you say negative 8p plus 48 must be greater or equal to 0. You take 8p to the right, so it becomes positive. So you say 48 is greater or equal to 8p. But in the actual sense, you're saying 8p is less or equal to 48. It's the same thing. Then you divide both sides by 8. Then you realize that any value of p that is less or equal to 6 will make sure that the roots of this equation are real. And then you should be fine.